Hi and welcome to this video. In this video we're going to work through this week's associated workshop, and we're going to examine the evidence tree and the various aspects of the evidence and artifacts that we find along the way. And as digital investigators we're going to attempt to answer some key questions that need to be answered. Along the way I hope that we'll also encounter some thought-provoking questions in that you as the investigator need to start asking and ponder and come up with your own conclusion. So as you can see, I'm currently in Autopsy. I've launched Autopsy and I'm going to open a recent case because in the previous video you would have ingested the hard drive image of lego.dd and gone through and run all the ingest modules. If you haven't done that, then you'll need to go back to the previous video and go through those steps to complete the ingest of that hard drive image in order to get to where we are now. Otherwise, you'll have nothing to examine until the ingest modules have completed running their analysis on the hard drive. So we're going to click the Open the Recent Case, and I'm going to go to Lego 1, which is the one that I've run before and ingested. So I'm going to click Open. And it'll take a little time to open all of the evidence tree. So you can see that the evidence tree has completed its load, and this is the view that you're met with as soon as you have imported everything again and you're good to go for your analysis. So as a digital investigator, you've been presented with this evidence, and the first thing you need to establish is there actually illegal content on this hard drive? You've been alerted to the type of material that's potentially on this drive, so you have an understanding of where you'd start looking to get an idea. In this instance, we've been told that this drive contains pictures of Lego content, so we know to start looking for pictures of that content. So the first thing I would do is open my File Views category in the evidence tree, and then go to File Types in the subcategory, and then I would look at by MIME type, and this can only be done after the ingest modules have completed running. And then I'll go into Image, followed by the various types of images that they are. I'll start out on JPEG, and you can see that there's a whole raft of different types of image file names. The file name is here. So on the left hand side you have the evidence tree, on the right hand side you have the details pane. You have the top component of the details pane and the bottom component of the details pane. So I'm going to start just clicking in general to identify whether or not we have illegal content, and we can see here that this is Lego and deemed as such illegal content. So we've confirmed that we have illegal content on this drive. So the answer is an affirmative on the fact that we have illegal content on this drive. So that's answered one of the first questions that we need to get out of the way. And then we would go through and we would start tagging the illegal content. And I've shown you in the previous video how to tag. You can just simply bookmark. The easiest way is simply go Control-B to bookmark, and it will highlight it as a likely notable image, and you can see that it gets a warning sign in the score column. And then down the bottom here in tags it will show up under bookmark. And you can see that it's highlighted accordingly. So you'd go through and you'd start tagging the various images that are deemed to be illegal and continuing to go down, untagging the ones that aren't. And moving through the various files so that you can get an accurate count of the overall extent of the illegal content. Now this may be a painstakingly long process, but as an investigator it's something that you just need to go through so that you can get an accurate understanding of the overall size of the crime. Another way you can also look for illegal content on the hard drive is at the time of configuring the ingest modules. If you recall, we set up keyword searches or a custom keyword search. Now the results of those are found under the analysis results category on the evidence tree, and within there you'll see keyword hits. So we'll expand that, and these first three are regular expression patterns that were checked previously, and they're just a standard regular expression pattern that look for generic patterns such as email addresses or credit card numbers and the like. But you can see that we've created a custom word search list called Lego, and that it's got its own little subcategory that we can expand. And now we can see that for each of the words we specified, we've got a number of hits that we can go through and confirm and check. So we can see that, and we can examine the various artifacts that have been returned based on the keyword search. And these would be cached web pages, and you can see that these are in the Firefox cache directory, where someone has accessed this website, and we can see that when we select it on the top part of the details pane, and we look at the hex value of it, we can see that in here on the right hand side, it's an HTML document and it stipulates Lego shop. So we know this is an illegal content, and we can go through and keep searching through the various artifacts that have been returned to confirm whether or not it is in fact a true positive and not a false positive. And here we have more cached data, which was an image file which shows Lego content. You'd work your way through and you confirm that the keyword search is actually a valid artifact or documentation. So going forward, now that we've established that there is illegal content on this hard drive, so we need to now establish how it actually got onto the hard drive. There are scenarios where a suspect will claim malware, or they left their computer unlocked, and so on. And these are the things that we need to validate and confirm or disprove. Like I've always said, we're not here to allocate guilt, nor are we here to push a specific view that so-and-so may be guilty. We're not looking to try and push that agenda or have a witch hunt. We're looking at logical, factual evidence to prove or disprove a case. So the first thing we're going to do is actually look at whether or not the computer was secured. And I'm going to confirm that in this instance, Jane, the suspect, claims she had no password. So we're going to confirm the user account that Jane claims to have been using and identify whether or not that had a password assigned to that account. So again, we go back to our evidence tree on the left, and we can scroll down to where it says OS accounts. So we can click here, and we are presented in the details pane on the right hand side a list of all of the accounts that were on this system at that time when the image was taken. So you can see a number of accounts that are present. You can see administrator, guest, and NUC. The rest are specific special Windows accounts and are just created by default, so they're not really user accounts. So we know that the account that Jane was using is the login name NUC, NUC. So we can click on that, and in the bottom section of the details pane, which is the right hand side of the window, bottom section, you have the details associated with that account. And you can see that you have various tabs on the bottom that are non-grayed out, that are active, that you can click on. On this occasion, we're going to click the OS account, and we're going to look at the details that this comes back with. And Autopsy shows us that this account, it doesn't expire, and there's no password required. So that means that it doesn't have a password. Now this is one method of proving that the account doesn't actually have a password. In terms of doing a digital forensics investigation, you'd need to do triangulation and confirm that with a number of methods to prove within all reasonable doubt that there was no password required, and to verify and validate your results. Because this is a workshop, I'm not going to go through the triangulation process, but in real life you would actually be required to do triangulation. So on the basis that we have an account that has no password required, then we can formally say that this computer wasn't secure. So does this exonerate Jane from the responsibility of having the content on the hard drive? Well, not necessarily. It just means that the computer wasn't secure. So we need to dig deeper to work out whether Jane is in actual fact exonerated, or we can implicate. So this is just the first stage of our investigation, and although it proves that the computer could be accessed by anyone, we now need to work out whether in fact that was the case. So the next thing that you want to have a look at is whether or not there was malware on this computer. And the way we would do that is that we would mount the image in a read-only mode and run it against a number of reputable virus scanning software utilities. This will confirm whether or not there was malware on the hard drive at the time of the incident. The suspect may claim that there was malware on the computer, and that was the reason that there was illegal content on this computer. So what we're going to do is that we're going to mount this hard drive using whatever utility that you're comfortable with. In this instance, I'm going to use FTK Imager to mount it. And in terms of triangulation, you could also mount it under Kali Linux, read-only, and run something like ClamAV across the hard drive as well as another reputable virus scanning utility. So I've just launched FTK Imager, as you can see on the screen. So now we're going to mount the image. We'll go to File, Image Mounting, and I'm going to look for the image file, which is where I've stashed my Lego DD. So you can see lego.dd. I only want to mount it as a logical drive. You can pick whatever letter you choose. The next available in my instance is F. And we're going to make sure that whatever, you can either choose a block device or a file system, but you need to make sure that this says read only. I'll leave it as the default, which is block device / read only, and I'm going to click mount. And down here in the mapped images box just below, you can see that that's now mapped as F drive. So within Windows Explorer now, you can see I have a new drive which says local disk F. And this is the file system located within this hard drive image. So I'm simply going to run a scan using Windows Defender, as Windows Defender is actually a reputable virus scanning utility. And that'll take a little while to run, and I'll come back when this is actually finished and we can see the results. And here you can see that we've now finished our scan and there are no threats found. So now we've established a couple of things. We're starting to form an overall picture. And now we need to try and start pulling things together to either exonerate or implicate the suspect. So one of the things that I would typically do is I would go to the user's home directory and start poking around to see what is there. Normally a person would download content from the internet, and one of the most logical places to store it is the user's home directory, downloads, or desktop, or some other directory that's hanging off of the user's home directory. So we can go and actually have a quick examination of their home directory and just see if we can find anything specific. So we go into the evidence tree and we expand the image file, and we'll get the directory tree as the user would have seen it on their own computer. So we go to users, NUC was the user account, so we'll select NUC, and within there we can start looking at the desktop, and we can see some things here. We can go to documents and have a look. A few more things here that we can examine, and we'll have a look at the downloads directory, and we can see that that has illegal content here. So now we know that the illegal content is actually in the user's or the suspect's home directory. So another thing to give consideration to is we've discovered the illegal content within the user's home directory. So we want to look at such data that's associated that Autopsy has provided us from the EXIF data within the images and the operating system data. So we want to look at the creation time and access time of these images. So in the one that I've highlighted, millenniumfalcon.png, you can see that the creation time was on the 16th of July 2019, but we can see that it was at 9:52 AM Australian Western Standard Time. So if you were a digital forensics investigator, what would that suggest to you? Like, is that an after hours time? Do you think someone could have accessed the suspect's computer remotely via remote desktop? Now, keeping in mind that if someone accesses your desktop via remote desktop, it logs whoever is on the desktop at the time, it logs them off and locks the screen whilst the other person is actually accessing it remotely. So do you think that would be something that would have been noticed, or the suspect might have highlighted to a co-worker at that time? In any case, looking at that time, what does that suggest to you? Give thought to a standard working day and what you would be doing as a normal employee during those hours. So we can have a look at the harley-davidson.png as well, and we also want to look at the creation time for that. Now that's at 7:30 in the morning. We'll keep that in mind. Is that a reasonable time for someone to be at work? It's something to keep in the back of your mind and remember when you're researching further. So when you're doing an investigation, it often helps to try and put yourself in the role of the suspect. And you have to give thought to, well, as an employee of the organisation, what would I possibly be doing at that point in time? One of the answers could be, we would have a look at, were we sending or receiving emails at that point in time? What does that mean if we were sending emails at that time? So we're going to have a quick look now, and we're going to go back to our evidence tree, and we're going to scroll down, and we're going to have a look at data artifacts category, and within there, we're going to look at email messages. We're going to expand that, and we're going to start looking at the Gmail or mail. So we're going to click on that, and you can see that the right hand side details pane has changed, and we can see Jane with her email account is highlighted, and we can see when emails were sent and received. So we asked previously, was 7:30 a reasonable time for Jane to be at work at a desk? Well, this is a good answer in that if you're logged into your email account and you've had to provide your credentials for your email, one would assume that you've physically typed them in at your desktop. So here's where we can actually align the times in which emails were sent or received with times that we would expect the suspect to be sitting at a desk. So we'll examine the bottom one where it's from Jane to K sent, and we're going to select that one, and the bottom section of the details pane will update to start showing the components of this artifact. And we can see here at the moment I've got data artifact, and down below I've got headers and text. At the moment text is highlighted, but if we can look at the headers, we can actually get a lot of information out of this. So if we can look at the received from, we can see it was received from gmail.com. So we know that we need to authenticate into gmail.com, Gmail. And we can also see that the date that it was sent was the 19th of July at 7:29. So again, give thought to what does this actually mean? So if you've had a person sending an email from their desktop at 7:30, is it reasonable to say, well, this person was or was not at their desk at the time when this illegal content appeared on the hard drive? And if that's the case, then was the PC accessed via remote control, as in remote desktop, in which case it would have logged the suspect off? So these are the questions you need to start thinking and asking of yourself as you're doing this investigation as the digital investigator. So rather than just following a bouncing ball, you need to start thinking outside the square and asking yourself different scenarios as to what would happen if this occurred and what would happen if that occurred. Whilst we're also looking at the email headers, we can have a look at the user agent, and we can see that it's Thunderbird. So we know that Thunderbird is an email client that you need to actually double click an icon to launch. So the fact that it's run from Thunderbird and not a web browser suggests that someone had to be sitting at the desktop at that time and logged into Jane's email account, providing those credentials associated with that email account. So when you wrap all that together, that presents itself a picture. And what does that picture suggest? So you need to start pulling the various components of these artifacts and the evidence together to form yourself an overall view or a picture. So in creating a specific timeline and aligning the various pieces of evidence together, you can say, well, yes, this person was sitting at this desktop when this content was created. Again, it's all about pulling together bits and pieces to form a conclusive view. So one of the last things we're going to have a look at now is within Autopsy, we have the ability to examine the user's web browsing history. So that's located within the evidence tree under data artifacts, and we can look at web bookmarks, web cookies, web downloads, web history. So these are the things that you'd start looking at. So we can look at web bookmarks. There's one bookmark. It's unremarkable. Moving on, web cookies. Again, unremarkable, but we can see that Jane uses live.com, which is the new domain of Hotmail. So we know that Jane has a Hotmail account. We now look at web downloads, and we can see that there have been a couple of downloads. We can see Hades.jpg and something called Lego Disney minifigure random bag set. So we can select that within the top part of the details pane, and we'll look at the source file metadata. So we can see that this was modified at a time when, in theory, the suspect should have been sitting at their desk. So now we can go into web history, and you can see that within Firefox, it stores the web history within an SQLite database. And we can examine that. We can select in the top part of the details pane, we can select places.sqlite, and then we can actually start looking at analysis results in the bottom section of the details pane, and we can see where the places that were visited by this user, and we can see that we have shop.lego.com, legocdn.com. So we have a view as to where this user was actually navigating within their browser. And we can look at the next one, and we go to analysis results, and we can see that they were searching for shop.lego.com. We go to application, and we go to Moz Places. You can see how I changed the tab to application and Moz Places. These are the places that this user has been to, and we can go through and search this list and get an understanding of where this user was navigating throughout the internet. So we can see the user was actually searching for the word Lego on a number of occasions, or Lego Batman. So again, combined with the other pieces of evidence, this starts to form a solid picture. So as the investigator, you need to pull this all together and start confirming or exonerating the user based on the evidence that you have discovered. So I hope that gives you an understanding of just the beginning of how we're going to use autopsy to start pulling together artifacts and evidence to work out and create a pattern of movement or a pattern of access and or being at a terminal based on fact that we've discovered, and not just simply guessing and assuming. So that covers this workshop on autopsy for the Lego component. And now we're going to move on to examining various components on another disk image that is included on Blackboard that you should have already downloaded. So I select close case on the previous Lego case, and now I've opened up the disk image that was Joe Favourite's USB 2009 etc .e01. So you should have downloaded that from Autopsy by now and ingested that with the standard modules within Autopsy and let it run to completion. So as I said before, that this is an example of examining the EXIF data that is contained or embedded within many images that are found or taken throughout the internet. So you can see that under File Views, File Types, by Mine Type, Image, we simply have JPEG images. There are no other images located on this USB stick. And we can select that, and in the right-hand details pane, we can start selecting those images, and we can see the content of those, and we can see that these are predominantly images of cats. So what we want to do now is, as I said, use Autopsy to extract the EXIF data so we can start examining various components of that data and make greater meaning from these images. So under analysis results in the evidence tree, we'll select EXIF metadata. And you can see that the details pane on the right has changed now. And for each image, we have EXIF data that is displayed in the top part of the details pane. And in the bottom part of the details pane, we can go through the various sections and look at the file metadata and look at the analysis results. And that also shows the EXIF metadata as well. So you can see here, we can see the device model and the device make of the camera that took these images, and we can see what time and date it was created and so on. And this is really important for some instances where you need to know specific aspects of an image for whatever reason. It's something that you just need to be aware of, that most images will typically contain some sort of EXIF data that you can extract and analyze. That's not always the case. Often there are images on the internet that have been stripped of all their EXIF data, and they have nothing there to be revealed, and are simply nothing other than an image with no attributable data attached to it. So that brings us to the end of this autopsy demonstration for doing a high-level digital analysis. I hope you managed to follow along, and thank you for your time.